Hello everyone, welcome to another Chemistry 151 GLA. James here, and today we're going to be looking at problems 5 and 8 in GLA number 14. Problem 5 reads, which solution contains more moles of sodium ions? 100 milliliters of 0.620 molar sodium chloride or 100 grams of 6.3% sodium carbonate solution. So the problem tells us that we have 0.620 molar sodium chloride, and we know the molar concentration is going to tell us the number of moles per liter in the solution. We're also given 100 milliliters, so if we convert that into liters, then we'll have this value here and this value, and we can calculate the number of moles in the solution. So I'll do that right here. We have 100 milliliters. We know there are 1,000 milliliters per 1 liter. So we'll divide these out. 100 divided by 1,000 is going to give us 0.1 liters. If I rearrange this equation to solve for the number of moles, I have the moles are equal to the molar concentration times the volume in liters. So from here, I can just plug these numbers in. This is going to be 0.1. Multiply these out. We have 0.1 times 0.620, and that's going to give us 0.062 moles of sodium. Next, we're going to look at the 100 gram solution of 6.3% sodium carbonate. So we'll start with what we're given, which is the 100 gram solution. We know that in the 100 gram solution, if 6.3% of it is sodium carbonate, that 6.3 grams of the 100 grams will be sodium carbonate. Then we can use the mass of sodium carbonate to convert into the moles of sodium carbonate. And the mass of sodium carbonate is 105.99 grams. And I'm just going to abbreviate sodium carbonate per 1 mole of sodium carbonate. And for every 1 mole of sodium carbonate, we have 2 moles of sodium. So from here, the 100 grams of the solution will cancel with the 100 grams of the solution. Grams of sodium carbonate will cancel here. Moles of sodium carbonate will cancel here, and our final answer will be left in moles of sodium. So we'll do 6.3 times 1 times 2 divided by 105.99. And we have 0.12 moles of sodium. So as you can see, 0.12 moles of sodium ions is going to be more than 0.062. So the solution that contains more sodium ions is going to be the solution that is 6.3% sodium carbonate. Next, we'll look at problem number 8. It reads 20 milliliters of a stock solution was diluted to 1 liter. The concentration of the final solution was 40 millimolars. What was the concentration of the stock solution? So what I'm going to do first is convert the milliliters of the stock solution to liters. We have 20 milliliters. We know that for every 1,000 milliliters, you have 1 liter. We'll do 20 divided by 1,000. Gives us 0.02 liters. We also want to convert the micromolar into molar. I'm sorry, millimolar into molar. So we have 40 millimolar. There are 1,000 millimolars in 1 molar. So this is just going to give us 0.04 molar. Initially, our volume is 0.02 liters. Our molar concentration, we don't know. After the dilution, so we'll say finally, our volume was 1 liter and the molar concentration was 0.04. We know that the molar concentration is equal to the moles per liter. We can rearrange this to solve for moles. So the number of moles is going to be equal to the molarity times the number of liters. So we can solve for the number of moles that we had at the end by plugging in the final values, which is going to be 0.04 times 1. That's just going to give us 0.04 moles. And now we can use this number of moles and this volume to solve for the molarity of the initial concentration. So M is equal to moles over liters, which is going to be 0.04 moles divided by 0.02 liters. And the initial concentration of the solution is 2 molar. Thanks guys, I'll see you guys next time.